Welcome, everyone, to the September club meeting of the Central Arkansas Astronomical Society. I know we've got a few new faces here tonight. Raise your hand if you are new, and we'll just kind of work our way around the room. Just kind of stand up and introduce yourself.
I'm Lola Parrott, and I'm her neighbor.
Oh, I've met you. Yeah, you were up here before. You're not entirely new.
I've been up here before.
My name is David Kiesling.
Okay. Glad to have you with us. Okay. Oh, someone else? Or?
I'm David Bell. I've been here.
Oh, okay. All right. Well, I'm glad to have all of you here tonight with us. Let's see. Rocky, I'm going to let you make an announcement here real quick. But before Rocky gets up, remember that on October 1st, next Saturday, is International Observe the Moon Night, and we'll be doing a star party out at Pinnacle Mountain State Park. And if you go to the website, the INOM website, and look at their resources page, there's moon maps of things to show people, visitors at your scope. So look over that list of things that are on that map and choose a few of those to show people through your scope on Saturday. Okay, Rocky, you want to?
I've got a presentation to make on for the Astro League one of the Astro League programs, the Carbon Star program. But first, I just want to talk a little bit about. Got a lot of new people here tonight. The Astro League has a lot of really good programs to help you get started, and gives you what they do is they give you lists of things to look at, and document a few things about it. You know, like what it looked like to you and stuff like that, and some of them are measure objects, binocular and telescope, constellations, learning the constellations, meteors. I wore my meteor one tonight in your honor. One of these is anyway. But there's like 65 or 70 different ones. But one we got tonight, Ed Swaim has earned the Carbon Star Award, which takes seeing 100 carbon stars. And if you they're pretty. They're pretty anyway, so he gets a certificate of 10. Yeah, never seen a carbon star. It can be pretty exciting.
I have the honor of introducing our speaker tonight. He's a friend of our family. This is Bill Pryor from the Arkansas Geological Survey. And his history of working at the survey, he was on the Lignite project. I believe you worked with my husband on that. He's the staff hydrologist. He's retiring soon after 43 years, of service to the state of Arkansas. And recently he was the principal author of a paper concerning meteorites. It's not published yet, but it's in review. And to those of you who've been here a long time, you will know that he is a former member of CAS in the 1990s, 80s and 90s. And Carl said to tell you hello. He couldn't come tonight, but he's going to talk to us tonight about meteorites and meteor wrongs. The wrongs are the ones are what all of the people of the state of Arkansas bring to him and ask him, is this a meteorite? So, Bill, so glad to have you here tonight.
Thank you. Yeah, I'm glad to be back anywhere. As a member of the geologic staff, part of our mission is obviously to serve the people of Arkansas. In that capacity, one of the things we do is that when somebody finds something unusual or pick up something and don't know what it is, they bring it to us for us to identify it or verify it. Fossils, particular rocks, mineral specimens and things of different types. Over the years, many people, of course, would bring crystals in usually quartz crystals, say, oh, do I have a diamond? Or if they have a piece of pyrite or some other metallic looking mineral that's a little yellow color, is it gold? No, we don't have gold in Arkansas. Now that you can see, the diamonds come from the diamond mine. So we've had lots of that, but it seems that especially over the last 10 years or so, we've had an upkick in people bringing us meteorites that they think they have picked up in somewhere in the state, or their grandpa gave it to them or something like that. Now, why is this? Well, if you happen to go online and look on eBay or any of these other places and look up what the going price of meteorite, any kind of meteorite is, meteorites are sold by the gram, not by the ounce, but they sell by the gram. And there being different types of meteorites, some of them are fairly common, some are very rare. And so therefore their quote commercial value can vary depending on what type of meteorite that is. And of course, the problem is that usually for us as geologists is when somebody says, oh, I found a diamond in somewhere in the Boston Mountains or North Arkansas or something. Well, we know that the diamonds come from South Arkansas, from Murfreesboro and stuff. So you can kind of equate where something should be coming from by where they pick it up. The problem with meteorites are they could come anywhere. I mean, any 1 square mile of the earth can collect a meteorite just as, or have a fall just as much as any other. So they can fall in people's backyards, they can fall in people's fields, side of the road. So that kind of guidance is kind of off the table. That said, also, if you look on the internet, you will see all kinds of pictures of, you can look up what various meteorites kind of look at. But again, looks can be deceiving. What most people do not publish is what are the things that can look like a meteorite that we euphemistically call meteorons. And as the reason that myself and Mike Howard have got together to write this pub is that to demonstrate that, especially here in central Arkansas, we have an abundance of different types of meteorons. Now, why is that? The reason is, in large part, and I'll show these to you, is in examples, is that we, for over 100 years, had the aluminum industry here in Arkansas, where they went and mined bauxite for the production of aluminum aluminum. They experimented with aluminum with various other elements and stuff like that, trying to come up with other alloys, something that would be stronger, have certain other characteristics than what pure aluminum would have. When these things don't work, well, before EPA and everything, well, we'll find a place to dump this mistake. Or grandpa saw something at the plant and brought it home. So we have an extra burden of trying to identify what some of this stuff is than you may normally find out in other parts of the country and stuff like that. Also, there are native earth rocks, minerals that people will think are meteorites and stuff like that. So there is, people find those, but here, especially in Central Arkansas, we have an extra batch of lookalikes or look-alongs. And so what I wanted to do first is kind of go over a little bit here. This is the geologic. use a pointer then. Okay, this is a geologic column, stratigraphic column for the Earth, basically 4.5 billion years. If you look down here, these circles in this column right here, and they're kind of faded up through here, but you see they're different sizes. Those denote recorded
Is there any way that we can tilt the camera down so that those of us on Zoom can see the samples that you have, Bill?
Or if you just held them up right above your head, we could see the top of your hair.
I'll hold them up. Is that okay? When I talk about them, I'll hold them up. Does that work? Okay. Okay. Anyway, the circles in that one column denote known meteorite impact structures. And if you look, there are several dozen of them in various sizes from around different parts of the world and everything. The one up here at the Cretaceous Tertiary boundary, that's the Chicxulub impact structure, the one that's attributed to the extinction of the dinosaurs. So we've certainly have been bombarded over geologic time with large impacts and stuff like that. So they do occur, and they have played a major role in especially on the history of life on Earth. Here, now, this is one of many classification charts for meteorites. And being the good scientists that we are, we like to make lots of little different categories and everything. Meteorites are basically based on their chemical composition and their morphology. What does the crystal actually, or the meteorite actually look like? What's in there? And the basis on that then is what are basically, we have your iron meteorites and your stony iron meteorites. They're differentiated. They are thought to be the leftover smashed portions of planetesimals that were redistributed back into the solar system by planetary collisions and everything when the solar system was forming over 4 billion years ago, and the fragments going back into space. The others, the chondrites, are believed to be more primordial, that they're basically leftover early solar system material that never was part of a larger solar body. They have been out basically floating in space, kind of aggregating together, but never part of another planet, that a larger planet that later then was smashed apart and everything like that. Now, that said, probably most meteoritic material that's floating out in the solar system is this chondrites. They're more rocky material than iron material. But as they come through the Earth's atmosphere, they being made of much lighter, more discernible elements and everything, they tend to mostly burn up. We don't see them reach the surface. So preferentially, we see more of the iron nickel meteorites actually get to the ground. And of course, them being iron and nickel, they're more easily distinguished from ordinary earth rocks and stuff. So we see far in any particular collection and everything, you're going to see far more iron nickel meteorites than you do the other the other categories and stuff. Excuse me. One of the characteristics of an iron meteorite, that is a Canyon Diablo meteorite. That is from that's the meteorite that hit that created meteor crater. You can.
Hey, Jim, can you put the camera on you instead of Ron?
Did everyone see that okay? Ron? Shake your head, yes.
Oh dear. But as I rotate this, you'll notice that there's little flashes of what that is are iron nickel crystals that make up the meteorite. Okay. And they're basically all glued together in one mass. The reason that you see the individual crystals are that there's two. One is that the nickel content in the material in each crystal is a little different than its neighbor.
It is just a delay. Not showing up.
Yeah, maybe too big, but let everybody just take a look at that.
Lost now. Is that undifferentiated?
No, this is a differentiate. This would have been from the core of a planetesimal. Okay, just like with the Earth, as the Earth came together, the heavier elements settled to the core, forming the core of the Earth that we get our heat and magnetic field from. The lighter elements, the more what we think of rock, has floated to the surface and the mantle and then on the crust and everything. So it's segregated by weight, basically. And so these planetesimals were big enough and lasted long enough for these elements to segregate into different layers, a core, mantle, a crust or something before they were smashed. And so as iron nickel meteorites, this is just, that's just a regular one. That's one from Texas. So they're more distinguishable. Again, they're heavy. Huh? Well, it can't, yeah. Also, they're being made of iron, they're attracted by a magnet. So if you have a piece of rock that has no attraction to a magnet, it'd be very doubtful that it would be a meteorite, unless it's one of the most extremely uncommon forms and stuff. But that is usually one of the first things we do when somebody brings something in is test it with a magnet, see if it's magnetic or not. If it's not, then it becomes a bit more problematic to know or not. That said, usually, of course, like a piece like that, it's heavy, it's iron-like. The only way to be able to really know what's on the inside is obviously would be to cut it and do a special chemical etching on that in order to reveal that pattern. That's usually a dead giveaway. Also, the fact that the iron in a meteorite will contain some percent of nickel. There are naturally occurring pretty pure iron minerals, even pure, almost pure iron. And, but it does not contain the nickel. So that's another certain chemical proof that if you've got this pattern, you've got the nickel content in there, then you know you pretty convincingly that you do have a real meteorite. That you have to do chemically, or of course nowadays they have what looks like a Buck Rogers ray gun that basically it's a 45,000 to $80,000 ray gun that you can put on a sample and basically pull the trigger, and it will give you a reading of what elements are in it and stuff. Unfortunately, I mean, it's a chemical lab in a gun, basically. The only problem is, being with the state and everything, that $80,000 for such a thing is something beyond our budgets right now. Huh? It gives you, well, there's two types. There's one that will give you straight elemental values, like how much iron's in it, how much copper's in it, how much zinc, things like that. The other would be if you've got and I think they're still testing that, is one that kind of does a crystallographic reading on the thing and would actually tell you what minerals those elements are in. We tried out such a device several years ago, and they still need to work on it. I mean, we gave them certain minerals that we knew what they were, and they still had some difficulty coming up with, oh, this is pyrite or this is something, because the things with something on a chart like this is that it's a range. If it's like a recipe. If you have so much of one element in there, it's one thing, but then if you introduce something else, it changes and boundaries into something else and stuff. So there's always kind of a bit of a chemical range when it comes to meteorites and to just ordinary rocks and minerals and stuff like that. They're kind of coalesce. So one of the other things are artifacts from impacts. That is from the Wells Creek structure, which if you pull up a geologic map of Tennessee, up there, the Tennessee River, between the Tennessee River and Nashville, near the Kentucky border, there is a kind of a circular area of disturbed geology there. And what that is that's a 300 million year old impact structure that struck Tennessee and left a crater about 5 miles across. And this material was formed at ground zero. When the meteorite came in and hit with that much force, it creates what is called a shatter cone. So basically, that points up. Looks like a little mini volcano, and then the same thing, the pressure waves creates these structures. No, that's still basically like a limestone rock, but that was there when that meteorite hit it. Yeah, and it's through the deflection through the material, and it's but that's a shatter cone. That's another indicator that you actually have a impact structure there. It's also, if you've heard about shock quartz in the bedrock, that if you have basically a meteor impact that's usually over a mile in diameter, then you're generating enough pressure, enough energy that you create things like shatter cones and shock quartz and everything like that. Structures that are impacts that are smaller than that, they just don't generate the necessary force to make material like that, evidence like that. Now, this, you have to kind of take that and just kind of turn it in the light. You'll notice that there's little metal flecks in that. that is a stony iron meteorite, and that's from North Africa. So you have little individual iron crystals in there that are suspended in otherwise a rocky matrix. So instead of like the pure iron meteorites, this is a combination of the two that they euphemistically call stony iron meteorites. So they think that stony iron meteorites may have more common from the mantle of a planetesimal, not fully congealed into solid iron like the iron meteorites would at the core of a planet, but more coming from the middle sections, like from the mantle of a planetesimal and stuff. This is a particular iron, and what you need to do is kind of hold it up to the light, and you can see the crystal, see through the green crystals. This is a particular type of stony iron called a palisade, and the crystals are suspended in an iron matrix, and the mineral is olivine, which is a high temperature, high density mineral that again probably indicates that it came from the more mantle area of a planetesimal. But just take that and you can hold it up to the light and you can see through the, see through the olivine crystals. Yeah. And those tend to be a little more, they are more, quote, valuable because they are a bit more rare, obviously, to get the combination of iron and that type of crystallinity into it is a bit more on the rare side. Now, to get back to kind of what the other part of the program is, what are the things that people get confused with when they go out and look for meteorites or think they find some, is what we euphemistically call the meteor wrongs. Now, these are natural materials. This is actually what they call a iron stone. It's made up of cemented. It's an iron stone, what we call iron stone. So that's basically iron cemented sand. They usually form in the freshwater environment in the aquifers and stuff. And so you can see that when they were very large, people like to call them cannonballs. But they come out in that round, they actually form that round shape while in the ground and everything like that. And they'll have when you use what we call a streak plate, they'll have a reddish brown streak on a plate, which that's an indication that it is basically iron oxide. It's not meteoritic material. Would be more metallic, leave a more metallic looking streak to it. Now, this is something that we have here in Arkansas. That's obviously very magnetic. And this actually comes from a place called Magnet Cove, Arkansas. And that's the reason it has that name, is that it has, this is lodestone. Yeah, people use lodestone for iron instruments, or they used to make needles out of it and make the first compasses and stuff, because it was magnetized, so it would pick up the Earth's magnetic field and point north. So that's one of the more common minerals here in Arkansas that people will confuse because it's obviously heavy. It's got iron in it and everything like that, but it is a native iron bearing mineral. That is, huh? No, what? Yeah. Also, they can come in. It wouldn't have not to have the nickel in it. Right. Also, it would have the iron in, like the pieces you have are almost pure metal. That has, if you went to analyze it, would have a certain percentage of oxygen combined with it. These are magnetite crystals that also come from Magnet Cove. They have that kind of a pyramid shape to them, what we call octahedral shape. Magnet Cove, Granite Mountain, and the Diamond Mine were all igneous intrusions that came up to or near the surface of the earth about 90 million years ago, and have been, the case of Granite Mountain and Magnet Cove, they were exposed over millions of years of erosion. The roof, the rock that was over them has been removed, and now the cooled igneous rock has been exposed and stuff. And what makes Magnet Cove unusual is that it does have such a high concentration of magnetite in it and stuff, not just your usual, say, granite or something like that that you usually find in subterranean igneous intrusions that have come up close to the surface and then congealed into solid rock and stuff. So they're kind of unusual. Granite Mountain, the rock there is not really granite. It doesn't have certain minerals in it that granite should have. It's actually what we call a cyanide. Not related to cyanide, the poison or anything, but there is a different rock type. But they call it Granite Mountain because people can sell granite. It sounds better than to call it something else. But anyway, so we have some unusual minerals that people do get confused with as far as meteors and stuff that people bring in. What we have abundance of here in Arkansas are man-made meteor rocks. Can anybody tell me what that is? It's one of the more common things that people bring to us. Obviously, because it's nice and shiny, it's different. Not exactly. It's actually one of the most common minerals, or I should say elements, that the earth is made out of. Nope. It's all one element. That's one chemical element. Silica.
Silica?
Silicon. That's pure silicon. What they basically do is they take like quartz crystals. Quartz crystals are silicon dioxide. You remove the oxygen, and that's what you're left. It's just a pure metal. And why do they do that? Well, for one thing, silicon chips. That's the basis for the wafers that they etch the microcircuitry on that goes into computer chips and stuff like that. That's the raw material right there. Again, they experimented with different things. So we have single element trash that people find that can be just silica. We had and people find it in the woods, they find it in grandpa's shop. It just turns up from time to time. And when they bring that in, I can whip that out and showing them an example of that, because it's, you know, it's nice and bright and shiny and all that. And they just know that that's very valuable. This is something that I would say is a common factor for a lot of different things that people bring in thinking that they're meteorites. And you can look at that, and what is it? One of its characteristics, it's full of holes. People think that meteorites, obviously, as they come through the atmosphere, they should have all these holes and everything in it. The meteorite would not survive if it was being burnt to that extent and everything. Meteorites, especially the iron nickel meteorites, have what they call regoliths in them, which they look like thumbprints, but they're just like dimples on the outside. They're not distinct little holes that go into the material itself. That's actually slag. You know, if you ever seen, or clinker, if you ever seen Christmas Story and the guys fighting the furnace and everything, and it's a clinker. Well, one of the residues that you have left over from burning coal is the unburnable iron mineral component to coal, and that's what this type of material gets left over. But people commonly see that, and that's again a very common. Anything that's gases escaping and stuff like that. Basically, you're vitrifying it, turning it into glass. Again, now this is another example of manufactured material that didn't turn out right. Any ideas of what this material is? Silicon carbide, like your wheels on a grinder and stuff like that. This is just material that, for whatever reason, it's kind of in this porous, loose state. Glued together. But I've seen big pieces of that actually show up at some of the rock shops. It'll have, you know, it'll be black and it'll have play of colors on it and stuff like that. It's just like, the shops will, yeah.
If you get an exciting one, hold it up by your left shoulder there.
Yeah, that is, and again, this is something that turns up because the rock shops, like in the Hot Springs, Mount Ida area, have tables of this stuff, and that's slag glass. People wonder why, but people buy it, you know, put it out in their yard, or it's just something pretty. And so the dealers can get a ton of this stuff and put it out there and people will buy it. And so occasionally people find glass where you wouldn't think they would. Who knows how it got there? But that is one of the things. Different types of alloys. Many years ago, we used to have a chemical lab. And so when these things came in, of course, at the time, most people were looking for silver, they were looking for gold, they were looking for platinum. And so at the time, we were able to take these materials and actually test them in our chem lab to know what elements were in there and stuff. So that's when we came up on some of these that we have that have, if you look on there, like it'll have maybe zinc, it may have chromium, it may have aluminum, it may have iron and stuff. So again, these are some of the unusual components these are just some, just again, just some of the different alloys that people find that we've been able to actually test to see what's in them. Antimony. So there's just all kinds of metallic concoctions that people have found in this area for decades around here. And so these are some of the things that they commonly get confused with. Oh, I found something bright and shiny and it was buried under 20 feet of ground. It's got to be a meteorite or something like that. So we get quite a bit of that. We get some stuff. I'm going to leave this in the bag. It doesn't even look like metal, but it's still magnetic. Am I running too long?
No, you're perfectly fine.
Okay. So again, we've had such a demand for over the years that have prompted us to want to try to better educate people on everything. Now, back in the 1980s, there was a man named Meteors that wrote a book on the meteorites that have been found in our actual verifiable meteorites found in Arkansas. There's been about 15 of them. Mike alluded to them in his paper. And then here are some of the locations where some of the actual meteorites have been found. Some of these have actually been found after falls. Okay, if everybody's familiar, an actual fall is when a meteorite has actually been tracked as it comes in and then tracked to its point of impact and recovered. So we've had a few of those. Hopefully once this gets the blessing of the administration of E&E that I work for, this will become another publication that will be either available on, if you wanted a printed copy, it'd be print on demand. Okay, of course, we'd have to charge for the printing, but it'd also be on the website. It will be available on the website. Also, it's got some of the major, we've had actually various meteorites, the Paragould meteorite among them, that weighs several hundred pounds that have been recovered over time. These are actually in museums in Europe. This is a picture of actually tektites. Anybody's heard of tektites? You can take these out of the bag if you want. Tektites are believed to be congealed earth material splatter, basically. Rocky material that when there's a big enough impact, it's kind of like the bombs that come out of a volcano. There's thrown, this material is liquefied, it's thrown through the atmosphere. It takes on a cylindrical shape as it travels through the air and basically congeals into glassy ovoids and stuff. Some, they're distributed in what they call tektite fields in certain parts of the world. Those particular ones come from Southeast Asia. Some of them have been traced back to certain particular meteor impacts. Others, we're still not sure what their point of origin is and stuff like that. But that is, again, like the shock quartz and the shatter cones and stuff like that are Earth-derived materials from meteor impacts and stuff like that. So you have materials that are altered by the impact that were Earth materials, and then of course you have what's left over of the meteorite itself. Yes. Like I said, the rest of this, there's a little ironstone accretions and stuff. Things like that. Again, that was kind of my impetus for wanting to do this particular publication, is not just to put out more pictures or more meteorites, but to give people an examples of some of the stuff that shows up, especially here in central Arkansas, that people get confused as being meteorites and stuff, to kind of a little bit give people an understanding that just because something's unusual doesn't necessarily mean it's going to be a meteorite. I mean, I understand that, you know, there's a lot of wanting it to be for various reasons, but in 20 years at looking at stuff, we really haven't had one winner yet. And somebody actually bringing in something that we know is. That said, we don't have a lab facility to be able to test conclusively. I mean, we can look at it, but when people do bring material in and it may, okay. We usually try to recommend that they go online. There is a website called Meteorites testing.org, outfit that will actually check a meteor. You know, if somebody wants to spend the money and have something tested and everything like that. But there's no institution that I'm aware of right now at this time that will do it in state. Most of these places are outside the state and other parts of the country and stuff like that for positively identifying material and stuff like that. Are there any questions?
Yeah, we've got a dark sky festival coming up in October. And we're going to have 10 UALRs. What are the chances of getting you or your co-author to come up?
I mean, that's possible. When?
October 21, 22.
Of this year?
Yeah, Buffalo River. Yeah.
Oh, okay.
State's first dark sky festival.
Well, if you'll shoot me an email and we'll see what we can do and everything. Yeah, I've seen one of our former geologists had some contacts with the physics department at Euler, and she actually had gotten access to at least photograph a lot. You know, they do have quite an extensive meteorite collection. I believe one of their former directors, I think it was John Williams, went, you know, kind of like a meteorite man type of thing. He went out to places like Australia and stuff like that when you could still do it and collect meteorites and stuff. So they have quite a extensive collection. I don't know what they, other than storing it, that they're doing anything else with it right now. Yeah. Yeah. So, right. And I mean, they've got some nice, some very nice big ones. I've seen them and stuff like that. A very nice, extensive collection some iron nickel meteorites and some others. So we, like I said, we don't have, the state does not have a meteor collection that I'm aware of. There are those large meteorites and pieces and stuff like that that mostly are in museums and places or private collections. After I'm gone, right, basically, of course, the meteorites I showed you tonight belong to myself. The meteor wrongs will stay with the agency. Just again to allow my successor to have access to something to be able to compare and show people when they bring stuff in. So they will have access to that. But, you know, there are just a limited number of Arkansas meteorites. Many of them, again, are in outside the state institutions and stuff. And scientifically and economically, they're very valuable and stuff. So we just have to wait for the next big to boost event or something like that. Yeah. Well, and they had one here a few months ago that landed. It was actually caught on dash cams that came in over Mississippi, Jackson, Mississippi, and they actually did find some of it in the swamps in Louisiana. They actually tracked it down and stuff. And of course, they had the one, what was it, 10, 12 years ago that flew over that city in Russia and busted out, busted out the windows and all that. And they found the big part of it actually in a nearby lake. And so they fished that out and stuff. So it can happen anytime, anywhere. But my favorite thing is I just got 2 calls this week from people that I know it's a meteorite. I just need you to verify that it's a meteorite, not to identify it, just verify, because I already know. And so I know it's got to be valuable. And so that's sometimes the kind of response we get from folks when they don't want to hear what they don't want to hear, kind of thing. They want to be told what they want to be told and stuff. So that's something we come into. Anything else? You're welcome.
It's good to see you again for a long time. The stony meteorites, they mostly big palms.
Do they what now?
A stony meteorite.
The stones?
They mostly big palms.
Not always necessarily. A lot of them, I know a lot of the carbonaceous have been found in, of course, a lot of meteorites are found in the desert areas. I mean, you got a sea of nothing but white sand, and then where's this black rock come from? That kind of thing. And Antarctica's exactly the same way, and even more so because it's not only just stuff. I've seen what they see as, a glacier moving along for tens of thousands, maybe even millions of years across Antarctica. And these things pepper them. Well, then the glacier buries them, but moves along and comes to an area where there is some melting take place. So these things come up and they aggregate there at the surface. So the glacier actually kind of concentrates them. If you're in the right place and know where to look, you find more. It's kind of like gold panning. You separate out the heavies from the fines, and glaciers bring them up. The ice goes away, and then so it sits there until somebody finds it. But then, in the meantime, maybe another one comes up. So they stand out, and nature kind of helps concentrate them. without destroying it. You can imagine just something anywhere else in the world, especially any kind of iron material or something like that. It's going to, as soon as it hits, it's going to start being altered. It's going to turn to rust and stuff eventually. So the surface of the earth, when it comes to meteorites, is very corrosive. These materials will break down into their constituent elements and stuff like that, and oxidize away and stuff. So you usually have to find them pretty quick, or they occur again in deserts where there's minimal moisture, minimum alteration and stuff, or polar ice caps, basically where they're frozen in place and stuff like that. So that's where a lot of them get turned up, is in these special environments.
Is there a latitude where meteor strikes are more prominent than others?
Not that I'm aware of. I mean, I've seen some. The problem is when you go so far back in geologic time, if you have a very old impact and it's been transported through continental drift, it may have totally changed from, let's say, in the far southern hemisphere, and now that impact is in the northern hemisphere. So it depends on how far back in time you go. I'm not aware if anybody has. I guess you would have to plot these impact structures and see if there's any particular location or any trend as to where they're occurring right now. But you would still, again, have to use only the last few million years to see if you see any kind of long-term pattern. Otherwise, you're introducing Earth's geologic factors into that.
That's interesting. Yeah, and maybe if it might be interesting if the moon, you could do that to see if it's like a long-term trend, if objects are coming,
That's one thing I'm glad you brought up. There are meteorites that have been derived from the moon. There are meteorites that are believed to have been derived from Mars. But there are some of the most rare meteorites, for obvious reasons, to be able to be blasted off another body like that and then eventually be able to land on Earth. So there are classifications for such much material. Of course, we have actual samples of the moon to compare those to. We're still waiting on samples from Mars, and they have sent, Japan and the United States have sent probes to sample asteroids. And I believe the Japanese probe has already returned with its samples. And so we'll have actual physical asteroid material to compare with over time.
That's interesting. Do you know of any new minerals that they've discovered from asteroids or on the moon or Mars?
If you look in our pub, Mike has identified probably at least a dozen minerals that are relatively found in the meteorites themselves. They're rather rare on Earth, so they seem to be kind of peculiar to meteorites and the ones that have been found here in Arkansas. Some unusual ones, but as far as I know, there's anything that that I'm aware of that's totally it's finding material that is a little different and stuff, but nothing like a super heavy element or something like that we didn't know about before. But there are some minerals that seem to be rather peculiar to meteorites. It's just like the fact that the meteorite that killed off the dinosaurs left a uridium signature. So there are certain elements that are more plentiful in asteroids than ordinary Earth rocks. Makes them different.
Thank you. It's an
Welcome.
excellent presentation.
All right, Michael, you still want to do your presentation?
It's 8 o'clock. So what I will do is I'll make my presentation, the first one next.
Sounds good. Thank you.
All right.
All right, folks, thank y'all once again for coming out. If y'all have any questions or anything, do not forget October 21st, 22nd, and 23rd also. Bruce? Okay, October 21st and 22nd up there right around Tyler Bend. Come on up. We'll be up there for the whole weekend, and you'll have a great time.
We might have a volunteers only thing on Thursday.
And if you're a volunteer, then come on up Thursday night. We're trying to work out something for that. Other than that, thank y'all very much.
Anybody?
And I hope y'all have a great evening. Look forward to seeing y'all next month.